One path to establishing trust in automated vehicle technology is to follow a standards-based engineering approach. This involves a number of standards that form a stack of different scope and levels of detail. At the vehicle safety level, FMVSS and NCAP, Euro NCAP, ensure the safety of basic vehicle functions. In other words, you know that the brakes will work, you know that the steering will work, and so on. Above that, there's a need for cybersecurity standards such as SAE J3061 and SAE 21434. Additionally, there's a need for functional safety standards such as ISO 26262 to cover equipment faults. Some aspects of automated vehicles go beyond the scope of 26262. That does not mean 26262 is inapplicable. It is very much applicable, but it doesn't cover everything, so additional standards are needed. Another level of standards beyond functional safety cover the dynamic driving function, sensing, sensor fusion, and so on. Those standards are covered by ISO 21448, the so-called SOTIF standard, and the SafeAD white paper, as well as ISO TR 4804. Those cover potential faults in sensing the environment and some edge cases. Even those standards do not cover everything because there's more to operating a fully autonomous vehicle than just being able to drive down the road. At the highest level, systems safety is covered by UL 4600, which covers safety beyond dynamic driving and also forms a framework for a safety case for the overall vehicle that makes sure no gaps have been left in stacking up the standards. UL 4600 helps make sure that everything's covered that needs to be covered to achieve system-level safety. This standard stack-up has been endorsed by the U.S. Department of Transportation, who says, quote, "This is exactly the way we wanted standards to be used." There's an associated U.S. Department of Transportation strategy document that lists these standards and says that conformance to a set of standards is the DOT strategy for ensuring safety.